Hi everyone, my name is Patrick. I am chairperson of Python Italia, and I work as a full-stack developer at Sync Studios, which is a creative agency in London, based in London. And you can find me as Patrick91 online, more or less everywhere. Being a full-stack developer in an agency, it's quite nice because you tend up to do short projects, so you easily can try new technology quite often. And today I'm going to talk about a new technology that I've been using over the last year or so. And first, let me explain why it's been created. So as you all know, the old web was more or less like a collection of documents where the user could interact with the pages just by clicking links or using forms. And you will usually have just one single server that's going to return all the pages. The pages could be generated dynamically or not, but that's not the point. But as the web evolved in what we can call the modern web or the web 2.0, the requirements have changed. We now have applications that run on mobile devices like smartwatches, phones, desktop devices like laptop, or even fridges, for example. And also we have more complex data structures. So we have different data sources, for example, it could be a PostgreSDB, Elasticsearch server, and so on. And so we used to build like gateways to gather all this information into one single API that can be used by all those the different devices. And we mainly use REST APIs, which is it's not a standard, so it's more like a design concept that basically says our API is a collection of resources, and you can use HTTP verbs to do operations on them. So you can get resource, delete them, edit, and so on. But REST is not perfect. You might have seen the talk 2 days ago about REST. There are some pitfalls that you have to consider when you're creating an API with it. I'm gonna go through a couple of them. So first one might be too many API calls. For example, we have an API that returns a user. So you do a GET request to user/ID, in this case /1, and then you can get a response like this, where you can say, oh, there is a name, a list of friends, an avatar. And this is quite nice because it's using the building blocks of the web, so we're using links, so on. But it's nice, but what if you need to get the list of the friends and then their names, for example? You need to do an API call for each of them. And one of the workarounds you can see is to create another endpoint where you can say, oh, I want the user with the list of friends expanded, for example. And so you get something like this. But what if you need to get the list of friends and the images? So you might end up to create another endpoint. And same if you just need the user with their avatar. And what if you have to create a mobile application where you just need to serve smaller images, because serving like a big image is not a good user experience. And this goes on and on if you have to create other pages and so on. And this is a huge problem if you have like a complex application, or if you have many devices, or if you have different pages. For example, Coursera, which is now migrating to GraphQL, at some point they had more than 1,000 different endpoints, which is a hell of a lot. And you can imagine trying to maintain this code base. It's really hard, especially if you, for example, if you hire a new developer, you have to get them up to speed, and it takes a lot of time. And also you have to maintain documentation, because if you have to use this API on a mobile application, you need to know all the different endpoints and the way you can fetch data. So you might say, oh, I have a simple API, so I just can return all the data. So you end up doing requests that are like returning too much information. And this is just a simple example, but for example, if we merge the previous API to have something that returns everything by default, you're basically having a bad user experience and also a developer experience, because you're returning data that's not needed by your clients usually. And this is a waste of bandwidth as well. So can we do better? I would say yes, we can extend REST, for example. There were some examples in the talk a couple of days ago. For example, you can add get parameters to say, oh, I want to expand these fields. I want to show a different shape of the response based on the device. I mean, but since it's not a standard, it's everyone is going to do it differently, and you still have to document it, which is one of the pain points, I think, at least for me, especially if I have to work with other front-end developers where I have to hand over the API. So GraphQL was created to resolve some of those issues and others. It's been created by Facebook around 2012, and it's been released as open source in 2015, and it's been adopted by major companies like GitHub, Twitter, of course Facebook as well, and Coursera, as you have seen before. So what is it? So first of all, even if there is graph in the name, it's not really about graph database, it's just a way to query the data. So one of the main definition is a query language for API, which basically means that you have a language that you can request data. And I'm going to show you some examples. But first, let me tell you that GraphQL is a specification. So there is no default implementation. The base implementation is using HTTP, but you can use any other protocol if you want. The HTTP implementation usually uses one single endpoint, which is usually /GraphQL, and you do a post request where you can send your queries. But what do you send to GraphQL? You basically send documents in this form, which is more or less similar to a JSON. So it's like a JSON without the actual values. You basically, in this case, you are saying, oh, return me the results for the user with their name, their email, and their friend's name. And the API is going to respond like this. Basically, it's going to return only the data that you actually requested. And something that's quite nice as well is the ability to have types. So everything in GraphQL has got a types, which is really important because, for example, you can have a build step where you can say, oh, check this query. If the query is not valid, you're not going to build the API, the application. It's just quite handy, and also allows you to create documentation without really bothering about it. You can have different types. You have integer, floats, strings, boolean, and any other user-defined type, which like the basic type is called scalar. And you can, for example, in the Python library, there is datetime as a type, which is quite handy. So you know that, for example, the date is always in that format. And also you have object types, which is basically a collection of fields and types. For example, in our previous API, we can have the type user, the object type user that's got a string that's required, an email that's required, and then a list of friends that's required as well. And then there's another object type, which is friend, which has got only a name. And yeah, the power of having types plus the introspection, which basically every GraphQL API by default has introspection enabled, allows you to explore the API without having to dig into the code. For example, there is an IDE that's called GraphQL, which allows you to test your queries in the browser without having to open the documentation. And as you can see, there is autocomplete documentation and everything in just one tool, which is quite handy. So far we only have seen queries, so we can only fetch data. If you want to do other operations, we need to use one of those three main operations. So query that we've already seen, which is basically a way to request data to the server. Then you have mutation, which is a way to modify and create data, but it's not really limited to modify and create data. You can also, for example, use a mutation to run a task or something else, which is quite handy. And then you have subscription, which is way similar to queries, but it's in real time. It's usually using WebSocket. So this is like a shortcut for a query. Since it's a common operation, they provided a way to do a query without having to type too much. The actual syntax is this one, see the extended syntax. So you have the operation name on top, and then there is a query name which is only used for debugging. It's mainly used for debugging. For example, if you need to have logs on the server, you can just add a query name, and then on the server you can find them by using this name. Then you can also have parameters, and then you have the list of fields that you wanna query. It's quite interesting that you can have arguments for each field. So for example, in this case, we can limit the number of friends that we can fetch, but we can also, for example, if we have like different languages, we can query by language, or we can change the unit of measurement, which is really helpful. Then mutation, it's pretty much similar. So you still have to query all the fields, and then you have the name of the operation, and the rest of the syntax is the same. And you can still like ask for the fields that you need to. And then you have subscription, it's just the same. So we are a Python conference, obviously we want to use this with Python. And we can, there is a library called Graphene, and you can install it like this. Just install pip install Graphene, and then you can use it, you import it, and then you create a class for the query. As I said, everything is is typed in GraphQL, so even the root query is a type. So you have object type. In this case, we have a query that only has one field, which is hello. And then for each field, you have to create a resolver function or method. That basically it's the code that's returning the data. It's fetching and returning the data. So for example, in this case, we have a field that's called hello, that's a string, and then the function is gonna return hello, hi DjangoCon. And then we get the schema passing in the query to the schema constructor, and then in this case, we're just executing the schema in here, but we obviously can use a post request. But yeah, we are a DjangoCon, so can we use this with Django? Can we use reuse our own models and forms with Django? Yes, we can. The same people that built Graphene, they made Graphene Django library, which has got quite a few interesting tools. So you can install like that, and then you have to install to add it to the installer apps, mainly for the static files for the IDE. And then you need to point out the schema. Then you need to add the path to the URLs, and you can add the graphical view, and you can also enable the IDE definition we've seen before. And then you can create your object type, and there is Django object type that's going to create an object type based on a model, for example. And then you return the query set in your resolver. I'm going to show you this in more detail in a second. There's also REST framework integration, which is quite handy if you already have REST framework serializer. It's similar to the Django object type, but only works for mutation for now. This is something I would like to work on maybe in this sprint or in the next one. But yeah, use it like this, and then you can reuse your serializer if you have some custom logic there. So instead of building the mutation by hand. So let's make a simple API. Let's suppose that we have these two models. So we have an author model just with a name, and then we have a post with title, body, and a foreign key to author. What we have to do first is to create the object types, which is quite simple with Graphene Django, because you just need to create a couple of classes and specify the model in the meta, and that's it. So you already have the object types. Then we have to create the query. So we create a simple class that extends object type, and then we define the post field, which is a list of post object type, and then we create a resolver that's going to return the post object, all the objects in the database. So let's quickly test this. Oops. So this is the idea I showed you before, and it's quite easy to test this. So we can do posts. Then we can fetch, for example, for the title, I can do the request and I can see all the posts I have in the database. But for example, if I need to get the author and the author name, I can just ask for it and it's going to return it without me having to do any other thing, just quietly. Oh no. Okay. So let's create the single post query as well. It's pretty much similar. The only difference that in this case we have an argument, because every field can have an argument, and the argument is propagated to the resolver function. I'm going to show you maybe this later a bit in how it works in the IDE. But yeah, this is what you have to do, for example, to do a simple query. Of course, you also want to allow the user to create posts, for example. And you do it using a mutation. You create a mutation extending graphene.mutation. You still have to define the fields that this mutation can return. So you can allow the user, for example, to return the post title or other information. And then you have to define the arguments, which are basically the argument of the mutation. You can consider a mutation like it's a simple function. And then you have a mutate function that in this case is going to create an author if it doesn't exist, and then it's going to return the create post mutation with the post object that we had just created. And then you have to create a mutation object with all the mutation fields. In this case, there is only create post, and then you pass it to the schema. Done. Let's test this quite quickly. So as I said, mutation you need to pass the operation name, then the field, you can pass the title. Everything, as I said, is auto-completed, so it's quite handy because I did this like in 5 minutes. I don't really remember what I did. Then you can get the post, and you can get the title, then you can get the author, for example, and the ID. So if I do this, it's going to create a new post, and oops, you can see in the list of the posts. It's probably somewhere. Yeah, it's over there, which is quite handy. And as I said, we can also create posts by ID. So for example, I can create the post with ID 1. And something I wanted to show you that I didn't really like at first is that Graphene by default, or even any GraphQL implementation in other language, they catch the errors for you. So if you have a server error, the error is gonna come up in the front end, which I'm not sure if it's nice, but sometimes it's really helpful. For example, if I'm trying to do trying to fetch a post that doesn't exist, I'm gonna get an error. So you have a list of errors there, and then you still have the data, but the post is null. So something I like of this, that if, for example, you can do multiple queries. So for example, if you do first, oops. So if you do multiple queries in a single request, you still can get the data that came through. So for example, you can see that there is a first is null because there was an error that doesn't exist, and then you still have the second title, which is quite handy if you have loads of data. For example, in a project that we are doing at work, we have different components in the page, like I don't know, 10 components, and we batch all the queries. So we only do one query like every 100 milliseconds, and if anything fails, it's not gonna break the app. Only the part that failed, it's not gonna show up, which is quite handy. Yeah. Okay, this is cool, at least from my point of view. But you still have to consider that this is a new technology, especially in the Python world. So the library is stable, but there might be some gotchas. So one of the main things is the security. One of the frequent asked question on the list on GitHub is authentication. How can I do authentication with GraphQL? Well, we are using HTTP, so you can reuse it. You reuse the HTTP blocks. So you can use, for example, Django session, which is quite easy. So you just say, well, you don't really have to do anything for using session. You can create a mutation to log in the user. You can use a form to log in them. And then you have to say to the front end, send the cookie as well when you do the request. And that's really easy. Or you can use others. So you can use JWT tokens, or you can use basic host. And then you can also use parameters. For example, if we in the create post mutation, we could add another field. For example, instead of having just create post with title and body, we can also pass a token. For example, we could authenticate the user using that parameter. This is handy if you have, for example, just a few mutations that require user authentication. You don't really want the user to deal with headers and stuff. Yeah, and then there is also permissions. There is no built-in feature in Graphene yet for permissions, so you cannot reuse Django permissions for now, at least. But one of the interesting things of GraphQL is that you can have permission on single fields. For example, if I'm authenticated user, if I'm an admin, I can, for example, return the email and not show the email to like normal users, which is quite handy. But you have to do this manually because for now there's no way to do it like with decorators or any other specific syntax. And also where you can have public and private fields. So for example, GitHub is doing this. They have a single GraphQL API that's public and private at the same time, but the fields that are only available for internal development, it's private, so it's not showing up even in documentation. It's quite handy, which is also interesting for me. And then you can have you have problem with malicious queries and caching. So malicious queries, we are giving the clients so much power, because you can say, oh, I want all these fields. I can also nest all of them. For example, you can nest it like this, which is might be a bit worrying if you, for example, do posts. Then you get the author, and then you have the post set, and then you do something like this. You can go on, and it's not going to complain. It's going to do the query anyway. But yeah, you might not want this, especially if you have complex queries, or you have someone that really wants to break your website, so they can nest it like 100 levels deep, and caching as well. So one of the way that you can fix these issues, one could be to use timeouts. So for example, if you have a request that's taking more than 1 second, you can drop it. This is something that Facebook is doing. They do, if the request is taking more than one second, we just drop it, because it's not a good user experience, and it's probably someone doing something wrong. So anyways, and you can also have a limit of the nesting. So for example, you can check the query. So if there is a field that's more than 3 levels deep, don't do the query, so just return an error, which is interesting as well. And then there is another one that GitHub is doing, is called query costs. So you can calculate the cost of a query. So you can give to each field a coefficient. So you can say, oh, this field costs 1, this field costs 10, and so on. So you can calculate how much this query is costing to you. And you can say, oh, I can only do queries that are less than 500, for example. And also you can have static queries, and this is going to also help you with caching. Static queries is a way to have queries that cannot be changed by the user. So for example, imagine if you have a website that's only used by you, you can have a build step where you fetch all the queries that are done by the client, and you can save them, and then you can, instead of doing a post request to the server, you can do a get request, say, oh, I want to do a query with this ID, and then the backend is gonna get the query for you, and it's gonna return the data, and it's easy to cache, because the query is not gonna change. It's only going to change if you do another deploy or so, which is quite handy. And also, if you only have static queries, you won't have any problem with like nesting or malicious queries, because the queries are limited to what you have. And I think this is something that Instagram is doing, because I was checking their code, and they send like a request to the GraphQL endpoint, passing an ID, which is a long ID with the query ID and the variables as well. Some consideration. I've been using GraphQL, I think, more or less for a year in a couple of projects, and we are using on other projects that are still being built. And I think it's quite handy, especially if you have to work with many developers, because I really love the fact that you have documentation built in. For example, I was working on an internal project that we have many different mutations. Every time I was finishing some mutation, I was telling to the front-end person that was going to build the form or the front-end part, say, oh, I've done this mutation, and it was say, okay, and I was checking the documentation by itself without having asking me to change something or how something works, which is quite handy. Yeah, I think it's quite nice. It's probably still early in the Python world, because this is a technology that's mainly used by big companies where they use JavaScript-based backend technology. And so we still have to, we can improve the library quite a lot. But yeah, I really would like to see people using this and improving the library. So if you have any question, you can feel free to ask me. Thank you.